So for this part of our course, we'll be doing section 3.5, solving equations containing fractions. So in the past um, lectures, we already did some equations which involved rational expression. So basically, we know how to solve this type of equations. So in order to solve an equation involving rational expressions or involving fractions, one may multiply both sides of the equation by the least common denominator or LCD, then solve the resulting equation. So this is your LCD method. So of course, the equation has denominators. You look at the factors of each denominator and then you construct or you identify the LCD. Okay, and once you know the LCD, you just need to multiply both sides of the equation by that LCD and the denominators will disappear. They will be canceled, okay, by some of the factors or all of the factors in the LCD. Okay, so eventually when you do this, you will just get, at least for our course, you will get linear equation or quadratic equation or at most cubic equation. Okay, now keep in mind that the denominators appearing in the rational expression must not be equal to 0. Okay, so I mentioned to you before that if you have a rational expression, okay, then all of the possible values for which that rational expression is defined is called the domain of the rational expression. And the domain of the rational expression does not contain all values of the variable that will make the denominator 0. Okay? So the domain will not contain all the values of the variables that will make the denominator 0. So keep in mind that the denominators appearing in the rational expression must not be equal to 0. Okay? So, we have here 5 over 4x equals 1 over x plus 1 and plus 3 over 2x. Okay? So for this, let us first write the conditions. Okay? For the x or for this equation to be defined, we do not want to have x equals 0. We do not want that. Why? Because if x equals 0, this will be undefined. Okay? Similarly, or in addition to that, we cannot have x plus 1 to be 0. Okay? X plus 1 to be 0. We don't want that. Or you have x cannot be equal to negative 1. Because again, this will be undefined. And in here, x equals 0 cannot, we cannot have that. It's already here. So the only two conditions for this equation to be at least valid is that your x cannot be 0 and your x cannot be negative 1. Okay? Now, let us try to solve the LCD. So in here, we see several factors. Okay? So if we write, say, p of x, let me write it here. If we write p of x to be your 4x, okay? This is your 4x. So the factors, let me write the factors in here, okay? The factors for p of x are 2, multiplicity 2. Remember that? Multiplicity 2. Multiplicity 2. Because you have 4. 2 times 2 or 2 squared, that's 4. That's the power of 2, okay, to get this 4. Okay, let me just move this here. So multiplicity 2. And then, of course, you have your x. Okay, so this is for your p of x. For q of x, we only have x plus 1. So the factors, it's just x plus 1. And then for the r of x, if we put this as 2x, the factors are 2 and x. Okay? And then how do we get the LCD? LCD is the product of all factors appearing. Okay, so we have 2, we have x, x plus 1. In here, we have again 2 and we have x. So this will be 2x times x plus 1. And aside from the factors appearing, we consider the highest power of the factor. Okay? So in here, you have 2 multiplicity 2, meaning 2 to the power 2. And then the other 2, the other factor 2, it has power 1. So we consider now 2 to the power 2 here. Okay? And then x here and x here. So both of them has or have power 1. So we'll just have x. And this is the only factor that we see for x plus 1. So it's just power 1. Which means that the LCD is 4x x plus 1. Okay? So 4x times x plus 1. So that's the LCD. We now multiply that LCD to both sides of the equation here. So let me write this 5 over 4x, and then I'll give some space there. This is equal to 1 over x plus 1 plus 3 over 2x. And then we multiply that LCD. 4x times x plus 1. And then on the other side here, we have 4xx plus 1. 4x x plus 1. Okay? So if we simplify this expression, of course, here the 4x will cancel this 4x here. So on the left-hand side, we will have 5. So 5x plus 1 equals. So again, just like what we did in the previous example, we distribute this. So for this guy here, 4x times x plus 1 multiplied to 1 over x. The x plus 1 will cancel this x plus 1 here. So we will only have 4x. Okay? And then plus 3 times. The x will cancel this x. And then you have 4 over 2. So 4 will cancel, the 2 here will cancel one of the 2's here. Okay? So we still have the 2 here and the x plus 1 here. So 3 times 2x plus 1. Okay? Following? Question? Okay, so again, so we have here the LCD. Okay, LCD is 4x plus 1, 4x plus 1, 4x times x plus 1, sorry, 4x times x plus 1. So this one, I think it's clear because We have the 4x and 4x, they will just cancel. So we will be left with x plus 1 in here. So 5 times x plus 1. For this part, again, we distribute. Okay, the x plus 1 will cancel this x plus 1. Okay, so I will be left with 4x. On the other hand, for this, so you have the 3 there in the numerator, you have the 3 there. The x here will cancel the x in the blue ink. So this x here will cancel the x here. Then this 2 here will cancel the 4 here, but you will still have 2 there. Is that clearer now? And then, of course, you will have 3 times 2 times x plus 1. Is that better? All right. And then we just simplify. So we'll have on the left-hand side, we have 5x plus 5. On the right-hand side, we have 4x plus. We have 3 times 2, that's 6 times x. Okay, 3 times 2, that's 6 times x. We have 6x. And then plus, you have 3 times 2 times 1. So 3 times 2 times 1, that's equal to 6. So we just distributed this. We have 3 times 2, that's 6. And then that 6 is distributed to x plus 1. Okay? So what we're going to do now is to move all the x's to the left-hand side of the equation and all the constants to the right-hand side of the equation. So in here, we have 5x minus 4x minus 6x. This is equal to, and then here you have 6 minus 5. So on the left-hand side, we have negative 5x. On the right-hand side, you have 1. And therefore, your x, this is equal to negative 1 over 5. Okay? And notice the only condition that we have in here is that your x cannot be 0 and your x cannot be negative 1. And in here, you have negative 1 over 5. Wouldn't it be positive? No, you have 6 minus 5, that's positive 1. Here, 5x minus 4x minus 6x, that's negative 5x. So if I divide everything by negative 5, you'll just have x equals negative 1 over 5. Okay? So you can do the checking for this part. Okay? Do the checking for this part. You substitute x equals negative 1/5 on this equation and you should get the equality. Okay? So try to verify the solution by doing the checking part. Question. Okay, so let us do the next example. Here, we have 2t over t squared minus 1 equals 1 over t minus 1 plus 2 over t plus 1. Okay? Sorry, there was a question. No solution. No, this is the solution. Sorry, I forgot to box that, but that is the solution. So verify it is a solution. by doing the checking part. Verify by substituting x equals -1/5 to the original equation, to the original equation. That's your checking part. Okay? So you replace your x equals -1/5 for each of x here, then you'll see that the equality will hold. So for this example, you have 2t over t squared minus 1 equals 1 over t minus 1 plus 2 over t plus 1. So first, let's write the conditions. We don't want t minus 1 to be 0, or this means your t cannot be positive 1. We also don't want t plus 1 to be 0, or that t cannot be negative 1. And then you will see that that's also the case in here, because you know t squared minus 1, okay? You know that t squared minus 1 can be factored into t minus 1 times t plus 1. Okay? But you have t minus 1 t plus 1 for the t squared minus 1. You have t minus 1 for this, and you have t plus 1 for this. So you can easily see that the LCD for this is actually t squared minus 1. Okay? And therefore, we have 2t over t squared minus 1. So what we're going to do is to multiply this with the LCD. So t squared minus 1 in here equals, you have 1 over t minus 1 plus 2 over t plus 1. And this is multiplied to the LCD t squared minus 1. Okay? So if you simplify this, t squared minus 1 here will cancel the t squared minus 1 here. So on the left-hand side, we'll just have 2t. And then on the right-hand side, we distribute again this to each of the addend here. Now, take note, t squared minus 1, that's t minus 1, t plus 1. And then, which means if we distributed this t squared minus 1 to this part, t minus 1 will be cancelled. So we will only have t plus 1 for that. So 1 over t minus 1 times t squared minus 1. The t minus 1 will cancel this. So we'll be left with t plus 1. Plus, you have the 2 here. So you have the 2. Then again, we distribute this to this part. This time, the t plus 1 will be cancelled. Okay? So we will only have t minus 1 for this part. Okay? So we solve this. We simplify. you have to t, this is equal to t plus 1 plus 2t minus 2. Okay? And we have 2t in here. We have 2t here. They are of different sides of the equation. So plus 2t here, there's plus 2t here, so they'll just cancel out. Some students do that, which is totally fine because it's also valid, it's correct, because they have the same coefficient and the same signs. So what will happen? On the left hand side, we have 0. On the right hand side, you still have t, and then you have 1 minus 2 here. So you have minus 1, or that t equals 1. Correct? But notice, your t cannot be 1. Okay? So, but t cannot be equal to 1, so there is no solution. So, there is no solution. Okay?
Sir, I have a question.
Sure.
If two squared minus one, t squared, sorry, minus one is equal to t minus one, t plus one, why do you only cancel out t minus one and not t plus one also?
Where?
In like the first line,
Uh-huh.
where you cancel out t minus one.
For this, yep.
Yeah. But if
That's
t,
why we have t plus 1.
well, yeah. So why did? Because
Because the only denominator here is t minus 1. The only denominator here it's t minus 1. So the only expression that will
oh,
be
okay,
cancelled
I
is
see. I
minus 1.
see. Thank you.
Yeah, you're welcome. Other questions or clarification?
Sir,
Yep.
do you mind explaining the conditions on top? Because I'm kind of confused, like to how that works.
Uh, since you have rational expressions, you don't want your denominator to be 0 because something over 0, some number over 0, it's not defined. So you don't want your denominators to be 0. So meaning, for example, for this, you have t minus 1 on the denominator, so you don't want t minus 1 to be 0. But that's
Okay.
the same as t cannot be equal to 1. Same is true with this guy here.
All right.
And since your t squared minus 1 is just t minus 1 and t plus 1, you already included the condition for t squared minus 1 in these two conditions here.
All right then.
Does that
Thank you.
answer your question?
A little bit, yeah.
Just
And I
keep
guess
in mind, if you have
the
a denominator, we don't want the denominator to be 0.
okay, so it can be less than zero or greater than zero.
Yeah, of course. It can be anything except for 0.
Okay. Because here's sort of like because it can be plus one or negative one, but
No, it just happened because, it's a coincidence. You have your t minus 1 in here and then t plus 1 in here. It could be other expressions, like what we will see in the next example.
all right. Thank you.
So with that, let us move to this next example. So you now have here 7s over s squared minus s minus 6 plus 2 over s minus 3 equals 1 over s plus 2. So what are the conditions? So first, uh, s squared minus s minus 6. Try to do the factoring. This is simply s minus 3 s plus 2. Okay? And this s minus 3 is also a denominator of this. This s plus 2 is also a denominator of this. So if they are the denominators, you don't want your s minus 3 to be 0. You also don't want uh, your s plus 2 to be 0. But this means that s cannot be 3. Here, s cannot be negative 2. And again, these two conditions will also include this because it's the factors of, they are the factors of s squared minus s minus 6. Okay? And moreover, you have the factors s squared minus s minus 6 to be s minus 3s plus 2. The other guy here, it's s minus 3, the denominator, I mean. And in here, the denominator is s plus 2, which means the LCD is simply the product. Okay? It's just the product. So also, LCD is simply the product s minus 3, s plus 2. Okay? So, again, we multiply the LCD to the left-hand side and to the right-hand side of the equation. And then we simplify the expressions. So we have 7s over s squared minus s minus 6 plus 2 over s minus 3. So we multiply this to the LCD. So let me put the LCD in factored form. S minus 3, s plus 2. And then on the other side, we have 1 over s plus 2 multiplied to the LCD. S minus 3, s plus 2. So if we distributed this to the other, to each of these, okay? So in here, we have to distribute this expression here to each of the addend here. So for this guy, the whole of s squared minus s minus 6 will be cancelled because this product here is s squared minus s minus 6, which means we have 7s in here plus we have the 2, and then in here the only expression that will be cancelled is s minus 3. So this will cancel this guy here. So we'll be left with s plus 2 there. And on the other side of the equation, the expression that will be cancelled is is s plus 2. So this cancels this guy here, which means we'll be left with s minus 3 only. And then we simplify and then solve for s. So on the left, we have 7s plus 2s plus 4. And then on the right, you have s minus 3. So we bring all the s's to the left-hand side of the equation, and then the constants to the other side of the equation. So in here, you have 7s plus 2s minus s. This is equal to minus 3 minus 4. Minus 3 minus 4. So in here, what do we get? 7, 9, 8. So 8s this is equal to negative 7, or that s is equal to negative 7 over 8. And notice the conditions are s cannot be 3, s cannot be negative 2, so this will be the solution. So you can verify this. Again, similar to the other one. So verify. So by verify, I mean you substitute this s equals negative 7 over 8 to the equation, and you should get the equality. Okay? Question. Okay?
Sir, do you mind explaining just how you did how you just wait, hold on. The second part when you were distributing the s minus 3 plus s. Yeah, that one.
This guy here.
Yeah.
So if we distributed this, so again, this guy here, this s minus 3s plus 2, it's this guy, and it's just your s squared minus s plus 6. So if I distributed it to this part, that s squared minus s minus 6 will be cancelled. So we will be left with 7s only, the numerator only, because this will cancel both of them, both of the factors here. On this guy, you have the 2, so you have the 2 here. So if we distribute this to this addend, s minus 3 will cancel, and we will be left with s plus 2. So 2 times s plus 2. Is that okay? So this guy here, it's your s squared minus s minus 6. That's why this will cancel this part here. All right. Other questions? Okay. Let us now go to our next problem. So we have 3 over 3 plus z minus z over 3 minus z equals z squared plus 9 over z squared minus 9. So here we take note z squared minus 9, this is equal to z minus 3, z plus 3. And then we have here the 3 plus z, it's just z plus 3. For this, your 3 minus z, keep in mind, so 3 minus z, this is only negative z minus 3. Okay? So basically, this equation, we can rewrite it this way. So this equation can be rewritten as 3 over z plus 3. You have the minus here, but 3 minus z, it's this guy here. So this one becomes plus z over z minus 3. And then this is equal to z squared plus 9 divided by z squared plus 9. Okay? And notice you have the z plus 3, z minus 3, and then you have your z squared minus 9. LCD here is z squared minus 9. Or let us write it as in factored form, z minus 3, z plus 3. Okay? Therefore, we multiply both sides of the equation. So you have 3z plus 3 plus z over z minus 3 times you have your z squared minus 9. I'll write it in factored form. So z minus 3, z plus 3. This is the left hand side. For the right hand side, you have z squared plus 9 divided by z squared minus 9. And this is multiplied to, this time I'll multiply the two factors to have z squared minus 9. So this guy here, it's the same as this. Which means on the left hand or on the right hand side, z squared minus 9 will cancel these two. While on the left hand side, if we distributed this again to this and to this, for this part, the z plus 3 will cancel the z plus 3 here. So we will only have 3 times z minus 3. For this part, we have the z minus 9 will, the z minus 3 will cancel the z minus 3 here. So we will have plus z times z plus 3. And of course, on the right hand side, you have your z squared plus 9. And then we just need to simplify this. Let us see what we can get from this equation. You have the 3z minus 9 plus we have the z squared plus 3z, and this is equal to z squared plus 9. So notice this z squared here will cancel the z squared here. So z squared is on both sides of the equation. Both of them have the same coefficient, positive 1, positive 1. So they can just cancel each other. And then we move this negative 9 to the other side. Okay, and then we add that 3z here and the 3z here. So we will get 6z. So 6z. And then in here you have 9 plus 9. So this guy here, you move it to the other side. So this is equal to 18. Z equals 18 over 9 over 6. But 18 over 6, that's just 3. However, look at this. I didn't put the condition here, but let us see. Let us write the condition here. We don't want our z minus 3 to be 0, which means that your z cannot be 3. We also don't want z plus 3 to be 0, or that your z cannot be negative 3. But after computation, after our computation here, we ended up with z equals 3. So there will be no solution. But let me write it here. But z cannot be 3, cannot be 3. So there is no solution. So there is no solution. Okay. Question.
Sir.
Yep.
So in the second step, like how come the negative turned into a positive?
Because your 3 minus z, that's minus of z minus 3. And you have negative here. So if I'm going to replace your 3 minus z as negative z minus 3, this negative will cancel this negative, so it becomes positive.
Okay. And second question, sir, like the 3 minus z and plus 3z, sorry, 3 plus z, like
Well, this one, you have a plus b, it's the same as b plus a, so it won't
yeah.
matter.
So like my question was like, let's say we just left it as is, like would it be wrong or?
Sure, but you just have to make sure that when you do the cancellation, a negative will come out,
Okay.
right? Because you have written it as z minus 3. So if you are going to cancel z minus 3, uh, if you want to cancel your 3 minus z using your z minus 3, a negative 1 will come out. That negative here.
Okay.
Okay?
Thanks.
You're welcome. Other questions? Okay. So next problem here. Find a number whose reciprocal multiplied by 12 is 4 less than that number. So find a number whose reciprocal multiplied by 12 is 4 less than that number. So we start by introducing our variable. Let's say let x be the number, be the desired number. Okay. Or possibly there are two of them or three of them or many of them. Okay. Then you have the reciprocal multiplied by 12. Then reciprocal is 1 over x. Okay, 1 over x multiplied by 12. This is, the reciprocal multiplied by 12 is 4 less than that number. So you have your x and then you subtract 4. So 4 less than that number. Okay? So the reciprocal multiplied by 12 is 4 less than the number. Did we interpret it correctly? Okay? So, solving for x, take note, x is a denominator here and there is no other denominators here. Well, except for that invisible one. So we multiply both sides by x. We'll have this 12 equals x minus 4 times x. But x minus 4 times x, this is x squared minus 4x. correct? And then we write this in standard position. In standard form. The standard form will be x squared minus 4x minus 12. This is equal to 0. So you put this on the other side, that becomes minus 12, and then we interchange. And then look at this, x squared minus 4x minus 12. You can solve this easily by factoring. By factoring, okay, you will have x minus 6, x minus 2, or x plus 2. This is equal to 0. Okay? So practice on your factoring if you still need to do more factoring. Okay? But this means you have x minus 6 equals 0, or x plus 2 equals 0. And therefore you have, sorry about that. So we had here x minus 6 equals 0, or x plus 2 equals 0, or this means that your x is equal to 6, or your x equals negative 2. Okay? And then you can check. You can check. If you get the reciprocal of this multiplied by 12, okay, that becomes 2. And 2 is 4 less than 6. Correct? Okay? So you can check that. Similarly for this, x equals negative 2. The reciprocal is negative 1/2. So 12 divided by negative 1/2, that's negative, sorry, the reciprocal of negative 2, it's negative 1/2. So 12 divided by negative 2, that's negative 6. And negative 6 is 4 less than negative 2. Okay? So do the checking part. So check that these values, meaning the x equals 6 and x equals negative 2, satisfy the conditions. The condition. Okay? Question. Next question here. This is our last example for this part of our lecture. And then we'll proceed with the next topic. So in here, we want to find 3 consecutive integers such that the double of the reciprocal of the middle one is the sum of the other 2 numbers. So find 3 consecutive integers such that the double of the reciprocal of the middle one is the sum of the other 2 numbers. So let's start by introducing our variables. So let x be the first number, be the first number. Okay, then the next two numbers are, then the next two numbers are x plus 1 and x plus 2. And x plus 2. Okay? And then according to the situation here, double of the middle one, x plus 1 is the middle one. Okay? So now, the double of the middle one, so 2, sorry, the double of the reciprocal of the middle one. So x plus 1 is the middle one. The reciprocal is 1 over x plus 1. Okay, so 2 times 1 over x plus 1. This is equal to the sum. Equal to the sum of the other two numbers. So the other two numbers are x and x plus 2. So this is equal to x plus x plus 2. Okay, and then let us simplify things here. You have your 2 over x plus 1. This is equal to 2x plus 2. But notice this one here, you can factor out the 2. You will get x plus 1. Okay? And what do we get in here? The 2 here will cancel the 2 here. And then we can multiply both sides of the equation by x plus 1. We will get what? So let's write 2 first. This is equal to 2 times x plus 1. And then there's another x plus 1 to be multiplied from here. So x plus 1 squared. Okay? And this gives us what? X plus 1 squared. This is equal to positive 1. Okay? Okay? So from here we will get what? We take the square root, remember one of the methods in order to solve your quadratic equation, the one in the form x squared equals p. Then, so if x squared equals p, then x equals plus square root of p minus square root of p, right? So that's the same thing here. We will have, so this means that we have x plus 1 equals plus 1 or minus 1. Okay? Or this means you have your x equals 1 minus 1 or x equals minus 1 minus 1. Or we have here x equals 0 or x equals negative 2. Okay? So we have the first value for our 3 consecutive integers. So the other values. So if x equals 0, the other values are 1 and 2. So those are the three consecutive integers, 0, 1, 2. If x equals negative 2, if x equals negative 2, the others are negative 1 and 0. And you can verify that one. Okay? So twice the middle one. So look at here. You have x equals 0, 1, and 2. Reciprocal of 1, that's still 1. And twice of the reciprocal, it's 2. And then you have your 0 plus 2, so you have the equality. Similarly for this, the middle one, it's negative 1. The reciprocal is negative 1. Twice that reciprocal, it's negative 2. And then the sum of the other two numbers, it's negative 2 plus 0. So you will have the equality. Okay? Question. Okay, so for this section, to practice, I want you to work on as many problems as you can on pages 64 to 65 of the 016 module. Okay, so that's the end of this part of the today's lecture.